But today we are going to start with a review of some special triangles that we see in geometry. This is going to help us to do our task today. If you cannot complete today's task, if you do not know how to do this skill, the test is going to be very challenging for you, and it's very possible that the rest of the quarter will be very challenging for you. Today is essential. It is a day you do not want your phone out. You do not want to be distracted. Today is the day you want to soak every bit of it in. It's not challenging, but it is new. Ready? Okay. First special triangle we want to talk about is a 30, 60, 90. This type of triangle comes up all the time in trigonometry. You learned about these once upon a time, and one of the reasons it's really cool is a 30, 60, 90 is exactly half of a 60, 60, 60. Agreed? So what's special about a 60, 60, 60? All the sides are the same. So therefore, if you cut it in half, that's going to help us predict some of the lengths, isn't it? So if I had an equilateral triangle where this side length was 10, what is then going to be this side length? 5. Everybody agreed? Does anybody remember what we do to get this side? Five roots of 3. Ava gave the shake of the head, which means y, right? It's like we just said something, like you just speak it into being and it's there. Okay, well, let's just figure it out. Suppose we call that side b. We would have 5 squared plus b squared is equal to 10 squared. Or 25 plus b squared is equal to 100. Or in other words, b squared is 75. Agreed? So I take the square root of both sides. B is equal to, what's the perfect square you can take out of 75? 25. So you get 5 roots of 3. See that? It'll work out that way every single time. So you don't have to do the Pythagorean theorem every time. You just write that side times the root of 3. That's it. So suppose I changed it a little bit. Suppose that this side was not 10. Suppose I had this side right here was 4. Then what would this side be? And what would this side be? 4 roots of 3. You used to spend like 2 days on that concept in geometry. Pretty straightforward now, right? Kind of remember it a little bit? That's the relationship. Comes up on the ACT. Helps if you know it right away. We'll go to another special right triangle. This is a 45, 45, 90. What can you tell me about a 45, 45, 90? Two sides are the same. We'll speak of the hypotenuse in a second. So if I have this side be a length of 6, what's this side? It's also 6. By definition, an isosceles right triangle have two sides that are the same. What do I do to get the hypotenuse? Yes, 6 roots of 2. Now, in that moment, we are going to go back to some of our friends who invoke the proofs are horrible and we don't understand them at all. We are going to prove that relationship right now. And it will be very, very simple. Isosceles right triangle where this is A, this is B, and this is C. Only if it's isosceles, then A and B are the same. Agreed? So I will write A squared plus A squared is equal to C squared. What's A squared plus A squared? 2A squared is equal to C squared. I will square root both sides. What's the perfect square you can take out of this? Right, so you have the square root of A squared times the square root of 2 is equal to C. And the square root of A squared is A, so A roots of 2 is equal to C. So we just proved that if you want to be able to produce that, you just take that times the root of 2. And you're like, that doesn't look like the proofs that we did. That's a proof. There's all sorts of different variations of proofs. I think that's pretty cool. Every time times the root of 2. Do you believe me? So let's take this piece right here and say, well, suppose it wasn't 6. Suppose it was 11. Then what's this side? And what's this? No big deal, right? Let's switch it up. Suppose I had 20 roots of 2. Then what's this side? 20, and this is 20. Suppose we change it up again. And suppose that this side is not 20 roots of 2. Suppose it's 3. Then what's that? To go from here to here, you multiply by the square root of 2. So to go from here to here, you divide by the root of 2. So you have 3 over the root of 2, which is the same as 3 roots of 2 over 2. Good? Okay. And then our last one, which sits right here, this is another 30, 60, 90 triangle, which you've already seen. And by the work we've done, I can tell that your geometry teacher did their job. You guys are smart. You understand everything quite well. We'll put it to one last test. Suppose that this is a measurement of 34. 34 on the hypotenuse. What is then the short side? 17. And what would be the length of the longer leg? 17 roots of 3. And if you understand that, you are ready for today's lesson. You understand the nature of our 30, 60, 90 and our 45, 45, 90 triangles. Again, you used to spend 2 days on that. We spent 6.5 minutes. The review happens quickly, right? Because it's in your brain. It's always there. It's the retrieving process. Do you know what helps you in the retrieval process? Sleep. When you get sleep after learning things, sleep, the reason, it's like, why should you have to sleep? People used to wonder, why do you have to sleep? Why can't you just eat something? You have more energy. Sleep is all about the brain being able to file that stuff away appropriately. And if you don't get enough sleep, it's just like you take everything in your house, you just shove it in your closet. You're like, oh, well, at least it's there. I know where it is. That's the problem, is that when you don't sleep, everything just gets shoved in a closet. You don't know where to find it. You don't know where the folders are. So getting sleep helps. Here we go. Find the terminal point on the unit circle determined by the following value t. This is our goal for today. We have 4 problems. We'll get to your homework. What is that coordinate? What is that coordinate on the unit circle? 1, 0. X value of 1, y value of 0. What is this coordinate? 0, 1. This one, -1, 0, and this one, 0, -1. Very good. Can you produce that on your own? I need you to be able to produce that continually on your own. You have to see it. That's going to come up time and time and time again. Okay, so now if we have a value of t equals pi over 4, or theta equals pi over 4, pi over 4 is how many degrees? 45. Notice how I don't want to sit and convert that all the time. That's why we've been talking about doing that conversion. We're actually going to make use of it. I draw a 45-degree angle. And I want to know where that angle crosses the unit circle. I want to know that coordinate. Okay? Can everybody agree by looking at it? It's not like a half and a half. So we want to find that spot. Well, fortunately, what I could do is I can use the geometry of our special right triangles. And so I have this special right triangle right here. What is the angle of the special right triangle? It is a 45, 45, 90. Any question how I came up with that? Okay, so as I have 45, 45, 90, I am working in the unit circle. What is the radius in the unit circle? One. That's why it's called the unit circle. 1 unit. This will always be 1. When we went from the leg to the hypotenuse, we multiplied by Square root of 2. So if I'm going to go from the hypotenuse to the leg, I should divide by the square root of 2. So 1 over the root of 2. Can I leave the square root of 2 in the denominator? No. So therefore, we have the root of 2 over 2. It is a 45, 45, 90. So therefore, the other side is also the root of 2 over 2. Therefore, the coordinate, that coordinate is composed of the horizontal length of the triangle. The horizontal length is the root of 2 over 2. And the vertical length of the triangle, which is the root of 2 over 2. That's the coordinate. Which, if you're wondering, is a decimal is like 0.7 and 0.7. So does it look like it's over 0.7, up 0.7? Hopefully it does. You know, I think so. Okay. Now, that took a little while, doesn't it? Yeah, I can actually look at this, and I can tell you that the terminal point is -1/2 negative root of 3 over 2. Like, I can just tell you that right away. You want to get fast at it? Then we'll get fast at it. Follow along, and I'll show you how to be quick. 4 pi over 3 is how many degrees? 60 times 4, which is 240. 240 degrees is the correct conversion. I'm going to draw that angle, and there it is. We don't have a special triangle for 240 degrees. So we always work with the reference angle. We talked about the reference angle yesterday. The reference angle is always formed against the x-axis or the y-axis. X-axis, so I draw my triangle back to the x-axis. If this is 180 degrees and this is 240 degrees, what is the angle that is right here? 60 is the reference angle. What kind of special right triangle does it produce? A 30, 60, 90. The radius of the 36 or of the radius of the unit circle is always 1. How does the shortest side of the 30, 60, 90 compare to the hypotenuse? Half. So half of 1 is 1/2. In our 30, 60, 90, what did you do to the short side to get the longer side? You multiply by. So therefore, you get the square root of 3 divided by 2. I now have enough information to produce my coordinate. My coordinate is the x value, which is -1/2 because you were in the third quadrant. And the y value is negative root of 3 over 2. See that? Not too bad, right? Letter C. We're not going to do -5 pi over 6. We're going to go theta is equal to -7 pi over 6. -7 pi over 6 is how many degrees? -210. Which quadrant will that place me in? Second quadrant, -180 and -210. Yes. I just decided to switch the problem because it would show us a second quadrant instead of another third quadrant. So I just switched it. Thank you for asking. I will draw my reference angle, my reference triangle. What is the angle formed against the x-axis here? 30 degrees, because we had 210 and 180, so 30 degrees. So I have a special 30, 60, 90 right triangle. What is the length of the hypotenuse always? 1. What's going to be the length of the short side? 1/2. What is going to be the length of the longer side? Root of 3 over 2. So my coordinate, what is the x value of the coordinate? Negative root of 3 over 2. And the y value is 1/2. Good. What can you tell me about negative pi over 2? Negative 90. In this case, sometimes people always want to sketch a triangle. You don't have to sketch a triangle. We're just wondering, what is the point which it crosses the unit circle? What is that coordinate right there, everybody? 0, negative 1. That's the terminal point. See it? Okay, it's very important we practice this right now as we try to convert things to memory. It's there. It now needs to go onto the working space. So the working space, as we try a few problems, take out your worksheet. Okay. And start working on problems 1, 2, 3, 4, 5, and 6. Produce the terminal points. The answer key is right here. Once we get to about, let's see, what time are we out of here? We're at 11. So at about 2:05, so about 6-7 minutes, I'm going to show you a pattern that develops, and I'm going to show you what to do with the rest of your assignment. So take about 5 minutes there. I'll come around and help you or guide you or clarify questions. But please do work on this. Eyes up here, eyes up here. So this is what I want you to see as we kind of work through. Some of you guys are hopefully noticing the pattern that develops. Did you notice that 0 and 1 are always together? Like you might end up with 0, 1, or 1, 0. 0 and 1 always end up together. And that happens if you're on an axis. So if you end up on an axis, you know you're going to be pairing 0 and 1 together. Do you notice how 1/2 and the root of 3 over 2 always go together? Is that for a 30, 60, 90 or for a 45, 45, 90? 30, 60, 90 will always pair 1/2 or root of 3 over 2. And then 45, 45 always ends up being the root of 2 over 2, right? Yeah. So if you look at any of these values right there, pick out one of those degrees, Taylor. Pick out one of the degrees. 330. Root of 3 over 2, negative 1/2. Done. Produced. See what I'm saying? So it can happen that quickly. In order to help you make it happen that quickly, one of the most important things is that you produce the unit circle. Turn to this part of your homework, which is the next page over. Those people who can produce the unit circle more quickly, you are set to have more success in the class, okay? So I would encourage you to practice it. I've had students in the past that do this and say, I don't think I did it quickly enough, and they produce it again and again and again. And all of a sudden, it makes a big difference for them. You are going to place the degree here. That is 0 degrees. This is 30 degrees, 45 degrees. We'll just do those 2 for right now, those 3. So you put the degree mark there. Next to it, you'll put the radian mark, which you've already talked about. This is 0 radians. How many radians is 30 degrees? Pi over 6 radians. 45 degrees is how many radians? Pi over 4 radians, okay? And now we produce the terminal point. The terminal point will be used throughout the course, so always be able to reference back to it. This coordinate is 1, 0. You've already listed the terminal point for 30 degrees. Do you remember what the x value was? Root of 3 over 2. And the y value was 1/2. You moved up to 45 degrees, and it was the root of 2 over 2. Root of 2 over 2. Now the fact is that you can just simply take the work that you did on the first 2 pages and begin to just transpose it over here. But what would be better is if you just got good at it on the first 2 pages, and then you said, okay, I'm going to notice the pattern and carry it all the way around. Do you know what I'm saying? I will talk about that later on. Then on the back side, then you can just have that practice again. So let's watch how you can do it quickly. I'm just going to choose 7 pi over 6. Now, I can see, does anybody see the terminal point right away? Okay, so here it's negative root of 3 over 2 and negative 1/2. I will show you how you can come up with that quickly, okay? 7 pi over 6 is how many degrees? 210? 210? Which is going to make what for a reference angle there? What's the reference angle? 30. So you have what kind of triangle? A 30, 60, 90. So what is going to be the short side? A half. And what's going to be that side? Root of 3 over 2. So you see how I very quickly came up with negative root of 3 over 2 and negative 1/2? You don't have to be able to do as quickly as I can. I get it. I've taught it for a while, but I will admit, folks, when I was sitting in your shoes, I remember trying to come up with it quickly, and I tried to visualize this piece. That's where I start. I visualize that, and I come up with the components. So, however you decide to do it, so be it, but this will be extra practice for you. Okay? Extra practice for you. So, plenty to do there. Plenty to do there. Good news or bad news? Got a lot of homework this unit. Good news, tomorrow's assignment is easy and short. Okay? Keep up with your homework. Good job. I'm subbing for Mr. Jensen this hour. We're going to go weld.
Where's your homework we did this morning?
Yep.
So for this part, how do you know what the
So you're going to add 360 degrees, which is 2 pi.
Yeah.
So 5 pi over 4 plus 8 pi over 4. I just converted it.
Okay.
See that now?